Have you ever thought about what would happen if the sun just vanished right in the middle of the day? For a few minutes, everything goes dark, quiet. The whole world just seems to hold its breath. Well, this isn't sci-fi. It's one of nature's greatest shows. So let's pull back the curtain on this amazing cosmic magic trick.
I mean, just picture it. You look up and you see this black disk sliding over the sun, and just like that, day turns into this weird, spooky twilight. You can suddenly see the sun's corona, its atmosphere, which is usually totally invisible, flaring out like a ghostly crown. It's an absolutely unforgettable sight, a solar eclipse, but it also raises a really big question.
Seriously, think about that for a second. The sun is about 400 times wider than our moon. So how on earth can this little rock completely blot out a giant star? It's a real David and Goliath situation. And the answer, believe it or not, isn't in some super complex physics, it's in something you've seen a million times. It's all about shadows.
Yeah, shadows. To understand a shadow so big it can cross a planet, we gotta go back to basics. We have to start with the one fundamental rule that makes every single shadow possible, from the biggest to the smallest. And it's actually really simple.
That's it. That's the golden rule. Light just doesn't do detours. It travels in a perfectly straight line. Now, scientists call this rectilinear propagation, which sounds super fancy, but it just means light goes straight. And once you really get that one idea, everything else about how shadows work, it all just clicks into place. So with that rule in mind, here's the textbook definition. You take an opaque object, something you can't see through, and you stick it in the path of that straight traveling light. Well, the light gets blocked. In the dark area right behind it where the light can't get to, that is a shadow. Simple, right? But this one concept is the key to unlocking some of the most jaw-dropping events in the whole universe. In fact, there's a basic recipe for every shadow, and it only needs 3 ingredients. First, gotta have a light source, a light bulb, a flashlight, a star. Second, you need your opaque object to do the blocking. And third, you need a screen for the shadow to fall on. Could be a wall, the ground, or hey, maybe even an entire planet. That's the whole recipe.
Okay, but you've probably noticed that shadows aren't all the same, right? Some are really dark and have sharp edges, and some are kind of fuzzy and gray. Well, that's because our simple little recipe has a really cool twist.
And this is where it gets super interesting. A tiny little pinpoint of light, it makes a simple, clean shadow. But most light sources, and this definitely includes our sun, are what we call extended sources. They're big, and that size makes a huge difference in the kind of shadow you get.
So think about it like this. When your light source is a tiny speck, you get one sharp, uniform shadow. But when the light source is big and wide, the shadow gets more complicated. Suddenly it has 2 parts. There's a super dark core in the middle, and then this fainter, kind of fuzzy edge shadow around it. Why? Well, it's because light from the edges of the big source can sneak around the object, but the light from the center gets completely blocked.
And these 2 parts have special names. That dark inner core, the region of total shadow, is called the umbra. If you're standing in the umbra, you can't see the light source at all. The lighter, fuzzy outer region is the penumbra. From there, you'd see the light source being only partially blocked. So you've got total shadow and partial shadow, umbra and penumbra. Got it? Good.
All right, umbra, penumbra. Those are the key pieces of the puzzle we needed. Now that we have them, we can zoom back out into space and finally solve the mystery of the eclipse.
So first, let's talk about the other type of eclipse, a lunar eclipse. Let's use our shadow recipe. The sun, it's our light source. Our planet, the Earth, is the big opaque object. And the moon, well, the moon acts as the screen. As it orbits us, the moon sails right through the giant shadow that Earth is constantly casting out into space. And that shadow has both parts, a dark umbra and a lighter penumbra.
So to boil it down, a lunar eclipse is all about alignment. You need the sun, the Earth, and the moon to line up perfectly in that exact order. Earth is the one in the middle, and its shadow falls on the moon.
And now for the main event, the solar eclipse. All we do is flip the order. Now the moon is the opaque object in the middle, and it casts its own shadow. And that shadow, which is much smaller, then goes racing across the surface of the Earth, which is now our screen.
And this really lays it all out, doesn't it? For a solar eclipse, the order is sun, moon, Earth. It's the moon's shadow falling on us. For a lunar eclipse, it's sun, Earth, moon. It's Earth's shadow falling on the moon. See? It's really just a question of who's in the middle casting the shadow.
And there it is. That's the answer to our big question. The reason the sun completely disappears from the sky is because for those few minutes, you are standing in the darkest part of the moon's shadow, its tiny umbra. If you're standing just next to it in the much wider penumbra, you'll only see a partial eclipse. It's that simple, and that amazing.
So what does all this really tell us? Well, to me, the big takeaway is that some of the most spectacular events in the universe are governed by the simplest rules we can see and play with every single day.
I mean, that one single beautiful principle, that light travels in straight lines, is responsible for everything from a simple shadow puppet you make on the wall to the shadow of an entire world falling on its moon. The universe, it turns out, uses the same rulebook for the small stuff and the big stuff.
And that really makes you wonder, doesn't it? If the secret to a solar eclipse is hidden in every shadow you've ever seen, what other huge cosmic secrets are just waiting for us, hiding in the simple, everyday things we see and never give a second thought? It's a pretty cool thing to think about.